In this lecture, let's discuss about web applications in general and how do we do that in Java in specific. A web application is just another software application that can be accessible on the web, which is nothing but internet. And the internet is accessed via HTTP protocol or HTTPS. And hence this involves an HTTP client and an HTTP server. So the application runs on the server. We typically call that as a web server. And end users like you and I access the same using a HTTP client, typically a browser, but it can be any other applications like another Java or Python application. It's the client which always sends a request, and based on the request, the server sends some response, and the response is going to be processed by your browser. And that's the content what we see on the browser when we visit a website. Website is a very generic name given to a location on the server, which is given a unique name in the entire world, which is called a domain name. But on the website, you may have a static application or a dynamic application. A static application consists of a bunch of HTML, CSS, JavaScript files. They just lie around on the server. A client visits that and gets the content, and the complete content is processed on the client side. So the server doesn't add any value other than just storing those files. Here is an example that you can see. The website kvinod.com has a resource here called About. When I access that, this is the content we see. So if I right click somewhere and then say inspect and then go to network and then do a reload again, you can see that it comes back with few files from my website. Number one is this resource, and if you click on that, it's nothing but an HTML content. You can see there is a bunch of response headers, request headers, but if you click on this response here, this is the HTML file that I kept in the server. That's right here. You can see that under kvinod.com there is a folder here called About. So the folder About contains two files here. Number one is the index.html and the other one is vinod.jpg. If I click on index.html, it's nothing but the same content what our browser saw earlier. Let's close this. And if you carefully observe the response, there is a reference to a style sheet here coming from a website called bootswatch.com. And that is the bootstrap.min.css, what you see here as the second request, and then the third one. And the Bootstrap itself has a reference to other files such as font files, and they are also being downloaded from the internet. There is one more here called favicon.ico, and it is not found in my website, hence that red color indicating an error. But the point is, when we access this website, all that happened was the client sends the request to an index.html. By default, index.html is the one that is fetched. You can see here it's not mentioning that, but it's the index.html. And then the references used in the index.html such as styles and JavaScript, they are all being retrieved along with images. And then everything else is being processed on the browser. So the server has no role other than just responding with that HTTP response. Whereas a dynamic web application, for example, is a little different because when the user visits the website, probably let's take an example of my website here, vinod.co. You can see that everybody sees the same content when they visit this particular page here. So to that extent, this is a static content. However, if I click on login here, then it's asking me what's the username and password and so on and so forth. But the moment I key in my username and password and then press enter, the content that I see here will be different than the content you may see when you log in. So here are some of the products that I have, and as a logged in user, you will have a different set of products. Similarly, if you visit a banking application like let's say icacbank.com, this page may be the same thing that you and I see, but the moment we log in, the content of the account would be totally different. And to facilitate this on the server side, you must have a program to do the same thing. And these programs can be written in different programming languages. Java is a very popular choice. And other than Java, you have the Microsoft .NET platform where you can use C# or VB.NET to code the server-side programs. There's a PHP, Python, and in the last decade, Node.js has also become very popular. And in this course, we are actually trying to do the same thing using Java. To make things easier, Java Community Process or JCP standardized the way a developer can develop web applications, because a web application has many requirements. These requirements can be considered as functional as well as non-functional. The functional requirements are requirements that are specific to a customer demand. For example, if I'm developing a banking application, there might be features like a user should log in, should be able to log out, view their account details, and so on and so forth. Whereas if I'm looking at a shopping cart application, the requirements are totally different. There may be customers, but the customers are free to register by themselves. They can have multiple accounts without having to pay for it. A customer may add items to their shopping cart or remove them, change the quantity, proceed to billing, add additional addresses, and so many things. Similarly, if I'm looking at a social media application, so the requirements are totally different. And these are all functional requirements. Non-functional requirements are typically common to all applications. For example, how to handle multiple users concurrently, how to secure the resources, how do I manage transactions, how do I convert the HTTP request information coming from the browser into a Java object. So a lot of requirements of an application can be categorized into non-functional requirements. JCP came up with something called Java EE or Java Enterprise Edition, in which they clearly separated functional and non-functional requirements. And JCP then made specifications for how to handle non-functional requirements, which are now called as containers. And in case of a web application, they are called web containers. And then how to address these functional requirements in the form of components that can be given to containers. So as a developer, I would be interested to create components that address the functional requirements and then deploy my components onto containers, which are created by other software developers or organizations. For example, we have a web container called Tomcat, which is from an organization called Apache. Likewise, you have Oracle WebLogic, you have WebSphere from IBM, you have Glassfish from Sun Microsystem. Adobe has something called JRun. So there are many third-party web containers that are available on which I can deploy my components. And as far as Java web applications are concerned, there is only one kind of component that you can create, which is called servlet. A servlet is a Java class that follows certain guidelines, or you can say implement certain contract interface, and then provide certain standard functions. So no matter how many servlets we have, or what kind of servlets we have, or what are the names of the servlets, a web container will only look into your classes and treat them as servlets and execute those standard contract functions. I may have additional functions in my class, but they are of no use to the container. So container always invokes the standard lifecycle functions of a servlet. So if I have to explain that in a nutshell, a request from the client is received by a container like Apache Tomcat, and then the container decides to invoke a function on a servlet which is coded by us as developers. And our function takes the parameters and other information sent by the client, which is given to me in the form of Java objects by the container, process them, give my response back to the container. Container will then give the response back to the client, because that's the one that received the client request in the first place. So as a component developer, I don't have to worry about any of the non-functional requirements, which are completely taken care of by the web containers. And since all the web containers take care of the non-functional requirements, it becomes a choice for us to choose between different containers based on the performance or pricing or any other factors. So when we develop our Java-based web applications, we will have different files such as HTML, CSS, JavaScript. And as far as Java is concerned, we may have servlets, our entity classes, or our business logic classes, our data access logic classes. There is also something called Java server pages, which are nothing but some HTML-like code, which eventually get converted into a servlet. We will discuss that in great detail later. But all these files exist in my computer, but we have to give them to a web container like Tomcat in a standard format, which is standardized by Java Community Process. We call this as a WAR file or a web archive. So it's nothing but a zip file that comprises of all the files in a standard folder structure. And this is standardized because now I can give this WAR file to any web container without having to worry about which is the web container that we are going to deploy on. So as a developer, when I'm developing a web application, I don't have to keep a specific web container in mind because my application is developed according to the standard set by Java EE, not by Apache or Oracle or IBM. So in the next lecture, let's discuss more about the web archive or the WAR file structure. So that's all for this lecture. See you in the next one.